creating equations from tables. Um, Going through these equations, again, we know that my equation is going to be in the form y equals m times x plus b, where m is my slope. So far we've talked about slope as rise over run. On a table it's harder to see what we actually rise and what we run, so we're going to call it change in y over change in x. And I'm going to use this little delta as change. Delta triangle, it's a Greek symbol for change. So on my table I'm going to worry more about this. B was my y-intercept. And I know that on a graph, that's where my line crosses the y-axis. But I also remember that it's always x equals 0. So it's going to be 0 comma some y value where x is 0. So that's going to help me in my table. So really the two new things about tables are this change in y. And it's not really new. It's just kind of a different thing that we're using. So b is going to be our 0 comma y, and m is going to be our change in y over change in x. So I like to draw those change in y columns and change in x, and then see what my changes are by using these little arrows. So from 2 to 5, I add 3. My change is a positive 3 from 5 to 8, and from 8 to 11. From 0 to 1, I add 1, and same from 1 to 2, and 2 to 3. So what I'm seeing is my change in y over my change in x is going to be 3 over 1, or just 3. So that's my m. My b has to be at the point where it's 0 comma y. So I notice that I have x is 0 right at the front of my table. So I lucked out, and my b is already given to me. My b is 2. So my equation is going to be y equals 3, or 3 over 1, x plus 2. Let's try another one. Here, if we make our change in y and our change in x columns, we change by going down 5 on the y side, and it looks like we're changing by going up 2 on the x side. So my slope is going to be a negative 5 over 2. Again, I luck out, and my 0 comma y is given to me, so b is going to be 15. And that means my equation is just going to be negative 5 over 2x plus 15. Let's do one more, and you'll notice in this table, 0 is not given. So we have 2 goes with 5, 4 goes with 8, 6 goes with 11. I like to write tables like this better, and 8 goes with 14. I don't like them when they're horizontal, because then I can add my columns, my change in y, my change in x. And here I see that I'm going up by 3. And over here, I'm going up by 2. So I know that my slope is going to be 3 over 2. But I'm a little confused because I don't have a 0. Well, we can just move this table down or go above the table and say, well, what if we went backwards? If we went backwards 2, this would be 0. And if we went, I'm going to use a different color here. If we went backwards 2, this would be 0. If we went backwards here, we'd have to go backwards 3 to follow the pattern, and this would be 2. And then I have my b. So b is going to be 2. My equation is going to be y equals 3 halves x plus 2. Let's go over here. 0, 3, 6, 9, 20, 11, 2, negative 7. Why don't you guys try this one? Pause the video and try this one. And now I'll go over the answers. Well, our change here is a negative 9, negative 9, negative 9. Over here we're going up 3, up 3, up 3. So my slope would be negative 9 over 3, or that's negative 3 over 1, or just negative 3. My b is given to me right there. So my equation, you should have gotten negative 3x All right, let's try another one. Let's skip those and let's just go to something like this. Try this one. Here are the answers. Change in y. We're going up 3. Over here, we're going up 2. I'm noticing. And so my m is 3 over 2. And my b is given to me. It just happens to be at the bottom of the table this time. My b is 12. So my equation is 3 over 2x plus 12. Let's try another one. Let's try this one. Go ahead and try it. Here's your answers. Oh, here I'm going down 8, down 8, down 8. Over here I'm going up 5, up 5, up 5. So my slope is negative 8 over 5. My y-intercept is given. And my equation is y equals negative 8 over 5 plus x plus 2. All right, let's try. I want to go over one other type that's pretty difficult. If you look here, like something like this, we know if we know a table is linear, then we can do we can look at rate of change even if the table is not nice. See how this table doesn't start, and I mean it goes from 6 to 9, back down to 3 to 5, back down to 0. But if it's linear, our change in y should always be the same ratio with the change in x. So if I think of negative 40 going to negative 40 or 64, well, that's me going down 24, right? If I go from 6 to 9, that's me going up 3. If I go from negative 64 to positive 16, that's me going up, and what would that be? That would be 48. That's me going up 48. 9 to 3 is me going down 6. Negative 16 to 32, that's me going down 16. 3 to 5, that's me going up 2. And negative 32 to 8 is me going down, nope, up 40. And 5 to 0 is down 5. What's interesting here is that negative 24, my change in y, should always be the same as my change in x. And it doesn't have to be the same numbers, just the same ratio. So negative 24 is going to be the same as negative 24 over 3 is going to be the same as 48 over negative 6. Is going to be the same as negative 16 over 2 is going to be the same as 40 over negative 5. All those reduce down to a negative 8 over 1. So that's my slope. And my y-intercept is given. And so my equation is y equals negative 8x plus 8. So that's a tough one. That's a thinker. You don't necessarily have to know that one. That's a little bit about tables and equations.